Hey everybody, going to be talking a lot about vaccines today, some COVID updates, some really cool stuff like that. I appreciate you guys participating in learning about science. If you have comments, questions, anything else, stick them in the old comment section. I will try to get them answered and address them in future episodes. This is one of the newer episodes that I've recorded, and since this time, I've been, before any interview, trying to put things out on Patreon, on social media, asking for questions from you guys. I did forget to give out any particular shout outs on this episode, but I just got so many responses. So many people were interested about vaccines that I just tried to see the questions that were asked the most over and over again, put those together, frame them in my own voice. And so just know that you guys absolutely did. Those of you following me on Instagram, Twitter, those sorts of things absolutely contributed into making this episode possible. And I did my very best to answer as many questions as I could put together that you guys were interested in. Super excited. People are very interested in this, and there is so much more to learn. This is an incredibly complicated topic, so it's really cool that you guys want to learn more and take part. So add more comments and questions down below. Enjoy today's episode. Here we are. Hello everybody, and welcome to the Here We Are podcast. Today I have an awesome guest, and I already know she's awesome because I already interviewed her, but you guys didn't get to see or hear her because I didn't download the file. However, she did, and we could have put it out, but classic academic, after a fantastic interview, she was like, "Can we do it again? I don't know." You're every academic I've ever talked to, by the way. It's what I like about it. I think it's one of my big bonds that I have with academics is the pathological self-doubt that.
I mean, I listened to that thing. I listened to it afterwards twice, and I sat down.
Don't do that.
Right afterwards. Right after we ended the interview, I was like, okay, I need to listen to this. I really want to make sure that I've got this right. And then I sent you corrections. I was like, nope, these are wrong.
Oh, well, I look forward to all the corrections this time. Jessica Brinkworth is our guest. Jessica, why don't you introduce yourself to the good people at home?
Oh, yeah. Thanks. I'm so happy to be here. So my name is Jessica Brinkworth. I'm an assistant professor in the Department of Anthropology at the University of Illinois Urbana-Champaign, and I study the evolution of the human immune system. I mainly focus on why some people get sick and some people don't, and also why some animals get sick and other animals don't, with a specific interest in severe infections. And I've spent an awful lot of time asking why certain people progress to, say, sepsis, for example, when they get pneumonia and other people don't. So that's what I do. A lot of my research involves probing cells with a fancy plastic stick, basically, and making them respond to terrible things like plague or toxoplasma, and even more mundane things like Staphylococcus aureus. So, and now I'm neck deep in COVID. So, that's what I do.
What was that last one that you said before COVID?
Staphylococcus aureus.
Yeah.
And E. coli. Yeah. So staph lives on you. E. coli does too. Most of the things that kill people every year live on them. So constitutively live on them, and then take advantage of a niche opening up when another infection happens. So staph is one of the leading killers worldwide. The number one thing that kills people in a normal non-pandemic year is lower respiratory infections. And the vast majority of those are caused by, outside of influenza, are caused by things that live in the lungs anyway. So, so the things that kill you tend to be the things that live with you.
I was looking at the causes of death recently, and it looks like COVID's on track to beat out the regular year's lower respiratory rates if it stays.
It's done. That was past. I mean, I feel like that trajectory was pretty as well established.
Because because what it's like 200,000 or something like that.
In the U.S. right now, it's 200,000. Yeah. So on a bad flu year, it's 60,000, and we passed May 8th is the last time that I checked and saw that we had passed it. I remember that date very specifically because I had to give a presentation on COVID that morning, and I was looking up like additional the next day's stats because that's how quickly things move, and we surpassed it. We were getting like 20 at the beginning of May. We had something like 20,000 cases a week that were being detected. Yeah, so
and that's I think that's like above, if I remember right. That's maybe above. So that's above accidents, which I think is just below it. And then, but above the lower respiratory, I believe is heart attacks and cancer.
So 70% of the population every year in the United States dies of coronary heart disease or something related. So you could broadly throw it into cerebrovascular diseases. And then about 20% from a broad group of cancers. And then after that, it's infectious disease. And after that, it's accident, all other cause mortality. Everything else is this really small percentage.
Now, when it comes to something like, because everyone's, not everyone, some of the people that want to see what they want to see in the number, it is amazing how much, I mean, you have to think, how much do I do this myself all of the time of like see the narrative that I want to see? I had a good example of this is I made a post about how I wish I could vaccinate myself against conspiracy theorists, and I took this page from this. I was just reading about this book, The Knowledge Illusion, and it's much about the kind of the Dunning-Kruger effect.
Oh yeah,
that kind of stuff. And like the community of a community of knowledge, like how much we know kind of depends on our network of people. And anyway, one of the things was addressing some of the misunderstandings that people have, and I posted on my Instagram story this page that was talking about how they wanted to see if they could message, the facts about vaccines causing autism. If they could, the CDC and information debunking that, what could you do to prime experimental groups to accept that knowledge? And they tried, like a powerful personal story. They showed images of kids with measles and like some other prime like that. And it actually made it worse. Like more people believed in that vaccines cause autism after seeing pictures of kids with measles.
Wow.
And it was a study. I'm sure I could pull it up in a heartbeat.
That plays exactly to the opposite of some of the information that we had when I was working for Health Canada. So to explain, before I was an academic, before I did my PhD, I worked as a policy analyst for Health Canada, and I worked in risk management at the beginning, which happened to coincide with SARS. And then I worked in biologic drug policy, and vaccines are a biologic drug. And the information that we had at the time that was largely coming out of the section of the department that handled controlled substances like tobacco was that if you showed a personal story of someone who was dying of cancer or who had to have a tracheotomy or things like that, that response, the response that was triggered in the audience, at least in the focus groups, was profoundly like, wow, that's really awful. And one of the reasons why, at least in Canada, the warnings on cigarette packages became big and involved things like...
I thought about this when I read this,
Right, involved things like rotting teeth. That was the one that, of all those images, like the erectile dysfunction and like all these other things that they put on these packages, the one that really like hit people gutturally was rotting teeth, right? Because A, it repulsed them.
You can see it.
They thought about themselves, right? And so when you're hearing these stories, these focus groups were indicating that like, oh, well, I thought about, they had deep empathy for this person and then they thought about themselves.
Yeah.
And so But I think that is probably, like, everybody knows that tobacco has these negative ramifications, right? That's accepted. I haven't seen a tobacco truther. I've seen people fighting tobacco bans, but I have never seen anyone who is fighting those bans saying things like, well, it doesn't kill you, right? Like that's accepted. That's,
right.
that's gold. I think instead with vaccines, we're looking at like a distrust in source, right? Like when it comes, I suspect that that's a big part of it. Like it doesn't matter if the government shows you that, here, these kids have measles, look how awful this is. Look at these people that have died and things like that. For someone, I think, who's already in a position of believing vaccines are bad, then, you're just providing more evidence because you're the authority and I don't trust the authority.
Yeah, well, that's exactly what happened. That's I think you're spot on because at least in this one little case, which most people really responded positively to my post where I kind of wrote this whole thing about like, I think we should absolutely be skeptical of medicine and science isn't perfect and all of that. And it makes it that much harder to be skeptical when there's conspiracy theorists saying lizard people are trying to track us with vaccines. and
lizard people trying to, that was awesome.
I mean, that's what's going around out there. I don't know if you are... how deep you've gotten into the conspiracy worlds, but it's...
Right, I've spent most of my time, I guess, fairly superficially arguing about autism, right?
That's the run-of-the-mill stuff. And then next level is like Bill Gates planned this so he could put microchips in us to track us with vaccines, which is there's
so much wrong with that.
Yeah, well, it's the people like look up those stories and read it on their phone, then enter in their email and social security number, so they'll get more stories like that. But what was interesting, and this was Brendan Nyhan, a political scientist at Dartmouth, ran this study. It is just one study. I'm not saying that whatever it was what it was, but yeah, it says in fact, some of the information backfired. After seeing images of sick children, parents expressed an increased belief in vaccine autism connection. And after reading the emotional story, parents were more likely to believe in serious vaccine side effects. Fantastic book, by the way. But anyway, this person who was kind of like giving me some... one was clearly like reading what he wanted to read in my post... and arguing with me, then like got on the story and was like, see, how can we trust scientists when this is the kind of stuff they're doing? They're trying to scare people into believing. I was like, no, you don't understand what the motivation of that test. You don't know what that test was about or what it was saying. Like,
would it help if I explained just how, compared to the years I've spent like gigging adjunct lecturing for like very little money in New York City and the years I spent in school not earning retirement savings, that the payoff once you are running your own lab is actually kind of low. Like I'm earning below what I was earning before I started my PhD now. And that's typical. And that's not to complain about my salary. I'm just saying that like there's no... The benefit for me anyway, and I think a lot of other people feel the same way, is the knowledge, right? The benefit is like, I'm going to learn this thing and maybe it contributes to a pile of things that help us move something forward. For me, in infectious disease, the thing has always been, I want to stop this bad thing from happening. So, and it's one thing to be involved in vaccine research, and those tend to be the people that get an awful lot of attention when there's a pandemic, for example.
Right.
And they're working ridiculous hours. I mean, like if I were to tell you my hours working at this they're pretty insane. Like it's not unusual for me to work, an 80-hour work week and I'm doing it now at home, getting up at like 3 a.m.
Well, I'm glad people. I'm glad I started doing videos so people can see the ivory tower that you have.
Like my wallpaper removing device, and two crappy yoga mats.
Where are you hiding from your family right now to do this interview?
Running around somewhere.
What is this room? A storage room or something?
Well, it was sold to us as a bedroom, but it has the furnace in it, so it is absolutely not a bedroom. It's a carbon monoxide hazard. So we use it as a craft room. It's where I work in here much of the time right now. But before then, it was like a place for my kids to like throw their pictures. It's not an organized room in any way.
Yeah. But you just got the email from Bill Gates saying if you ever got to do media with at all, make sure and make your mansion look like... I
cannot have my champagne out on the table. I mean, to be clear, I think like there's no benefit. It's not like I'm working for a large pharmaceutical company. And even the people that are working within pharmaceutical companies have a very different approach to this too, right? So like for every agent for every like agent that makes it to market, for every drug that makes it to market, there's something like 700 compounds that have been screened in advance. The amount of time and money that goes into just finding something, especially in experimental science where like there's no results guaranteed. And if you don't get a result, you don't know if it's because the experiment didn't work or if you did something wrong, or if really the thing that you were testing was supposed to produce no result. Like, so it's such I would say that like the healthiest thing I learned over the course of trying to complete a dissertation was that experimental work is like 95% failure. Mm-hmm. And so you have to very, very quickly adapt to failing, like being used to getting up every single day, working a long day, and then not getting anything out of it. We have experiments that run for a year, I got up every single morning for experiments that were taking weeks to run, and every single one of them failed. Every single one failed. Same experiment over and over again, slightly different modifications, every single one failed.
Wow. So you should be a comedian. Way less work and you still get all the same failure.
All the same failure. But I mean that's the thing. I guess it's just that like the income is fair. It's nice income. I'm happy, but it's not glorious, right? It's public servant level income. Yeah. And so I'm not popping bottles of champagne, and the work hours
which, by the way, champagne's not that expensive.
No, that's true, but I'm absolutely not popping it anyway because I just don't have the cash to buy it. But like, it's just one of these things. If you work single-mindedly to do this thing, so I would say the vast majority of people that are working to do it are working honestly, right? They're working from an honest interest. You have to be passionate about it anyway. But minimally, because otherwise it's really hard to get up and do it in the morning. But there are bad actors. So to be clear, there have been bad actors. And the number one most dangerous bad actor that I can think of is Andrew Wakefield, right? Who's the source of this exact problem that we're talking about.
Who is that?
So Andrew Wakefield was the investigator that first published a paper connecting measles infections to autism. And that paper in the first year was all the other co-authors pulled themselves off of it. And then, so that was published, I want to say in 89 or 92. It's around the early 90s. And then eventually the paper was pulled entirely, and he, I believe now, is unlicensed. And the reason why isn't because this paper connected a measles infection to autism. It's because to get the paper completed, he went to a child's birthday party and sampled kids for it without consent.
Oh, wow.
It is patently against the law. So that's the first thing. And then his history with this, because it was a controversial paper when it came out anyway, not because he didn't get consent. That was discovered in the course of the investigations into him. But because when the paper was refuted,
how did I guess that he had books that he was peddling?
Yeah, he's a big deal guy. When it was refuted, the target changed. So that the narrative around this is continually changed. So at one point it was like, well, it's not the infection, it's the vaccine. It's not the vaccine, it's the preservatives in the vaccine. It's not that, the target keeps moving. And I think what upsets me the most about this is that it's had this massive international fallout. Mm-hmm. I don't know what his motivations were, other than, at least at the beginning, to initially publish. But it takes advantage of people who are actually really struggling. That's the saddest thing about it. It takes advantage of people who are really struggling, who really want answers, who really want to protect their kids, who feel guilty that their children have a problem. And so, are that their route is going to be, through life is going to be atypical.
Yeah.
Not to problematize autism. I mean, it's such a big spectrum disease. There's disorder. There's many different ways of thinking about it. But
it's probably not something a parent would wish for.
I don't know. I think the good way to think about it is maybe, at least for some people, one of my friends described it to me like this, which is that it's here, it exists, it's an atypical path. And she is a kid who is really far on the spectrum. And so, they have a lot of challenges that are different than, what I have to go through with my kids every day. But in any case, so I'm not an autism specialist.
Yeah, no, I can get a hold of autism people, no problem. Yeah. I've had them on before. But more kind of in line with what we're saying, because this isn't like, I'm not a fan of big pharma. I have a show that I often have advocated for more psychedelic research and some of the kind of things that went into the scheduling system that we're fairly corrupt and whatnot. I'm not naive enough to think that the world is free of corruption and everything else. It's just,
pharmaceutical companies are not benevolent creatures, right?
No.
They're a creature of a corporate world. So they how was it put in the book Corporation? They describe corporations as sociopathic.
Yeah.
You remember that?
Yeah, I think I saw the documentary.
Yeah, I think I cheated too, because it's a really big book. Sorry, not to say that watching a doc is like cheating, but yeah, I mean, they're motivated by very different things. If you're a publicly shared company, you're motivated by maintaining the confidence of your shareholders, right? And maintaining market and getting return on investment. You're not motivated necessarily by like people suffering. If that were the case, there wouldn't be orphan drug legislation to ensure that drugs for Parkinson's, for example, get produced, right?
Yeah.
The government has to invest to ensure that those things make it to market.
Right. I mean, because I kind of looked at, my understanding was that kind of probably for the reasons that you said, vaccines don't seem terribly, like I'm bipolar. I'm supposed to, if I go to a psychiatrist, I'm supposed to be on mood stabilizers. I don't trust them. Plus it's fun to tell people that I'm supposed to be on meds and I'm not. That's always a good vibe to have a conversation with a good intro stranger. But I've had people that research depression that are skeptical about antidepressants, and that's, talking about a pill that you give someone every day that is like really seemingly very big money, that is potentially addictive and everything else. It just seems like quite a bit more motivation than a vaccine that's preventative and potentially is stopping further treatments of more expensive and therefore maybe profitable things.
Right, yeah, I suppose, right? It's no Lipitor. I mean,
right. Or Viagra for, I mean, if you want to make money, get into the erection business. That's
right. Yeah. So I think but a couple of things, right? So there are people who own patents, and then there's generics. So when something becomes available for what they call subsequent entry, which is when a drug that has been approved is now the patent's open and other people can produce it under its like proper name as opposed to its fancy marketing name. So, you know, there's things like that, right? So certain drugs, so for example, a lot of the antidepressants that have been around for like 40 years are it's subsequent entry now, right? Like you go to buy Effexor or something, or Lexapro or something like that. Those drugs are available in generic forms. And the original company sees no profit from that, right? That's something that generics are seeing specifically. But that said, with flu vaccinations, for example, there's an awful lot, in most countries, there's an awful lot that goes into price controlling. An awful lot of effort goes into controlling the prices of drugs that are broadly seen as being needed on the market. And like in Canada, drug prices get capped. That's part of the legislation. You can't come in and say this drug is going to be $500, $600. If reasonably we say that it has to be less. So there's this active federal hand that goes around limiting what you can charge someone for, especially for life-saving drugs. Like that's just, you know, you can't. This problem that we have here that started with Turing around a drug for toxoplasma, or the stuff around insulin, that's not happening in a lot of other nations. And that's because there's no drug cap legislation here.
Didn't that one guy go to jail a few years ago? That Pharma bro?
Shkreli.
I don't expect you to remember.
Last name, he did. He went to prison, though, not for... I think he originally went... He was up on a couple of different charges. I believe he went in for trying to get a piece of Hillary Clinton's hair, or that was coincident to him lying to investors in a scam before Turing. One of the two. He was up for a bunch of charges. The guy has some issues.
Yeah.
Professionally, he has some problems. But just to say really fast, I mean, around vaccination could be seen as bread and butter for a corporation, but there's lots and lots of producers. And the way that, say, the flu vaccine works is, and vaccines, a number of vaccines work this way, is that federal governments put a bid out. Around the world, they put a bid out and say, like, here's what we're willing to pay for this year's vaccines. And then companies compete for the bid. And then a company's chosen and they produce the vast majority of that vaccine for that nation. And in the flu vaccine market, what this means is that generally, since lots and lots of different companies make the flu vaccine, and they all make a vaccine based on the same flu strains, targeting the same, antigens, like the same protein structures on the outside of the flu virus. But the equipment you make a vaccine in is the vaccine, because when you make a vaccine, you have to use living things and you use components from living things. So one vaccine that's made by one company in one building is not the same as that vaccine being made even by that same company in another building, because every single thing you do informs the biology of the things that are going to make the vaccine. So because of that, every single vaccine that every country gets is a fundamentally different vaccine, even if it's by the same manufacturer. And so what happens after the vaccines are all bought up is that there's this post-market trading so that everybody ensures that they've got a whole bunch of different types of the same flu vaccine. Does that make sense? Yeah. None of that benefits the companies directly, right? That's not this post-market trading and selling. They're not seeing profit on that either. So that's not to say that they're benevolent, but it's that it's kind of complicated. And so there's a big difference between pushing antidepressants or, I don't know, Lipitor or whatever drug, an anti-acne drug or something at a population, and developing a vaccine that's broadly needed internationally every year and is traded in this way. I can't think of very many other drugs that are traded that way.
Well, okay, so that's, I wanted to address it because it does seem like that's becoming such a popular narrative, and I've always had friends that were conspiracy theorists, and for much of my life, I thought that they were outliers, and now it's becoming more and more popular. So I kind of want to address that. But I think that the average person has legitimate concerns of being of one, life is very complicated and there's a lot to learn, and you're giving your child something, and I mean, vaccines and any other medicine aren't risk-free, right? Like, hey, how do we, with something like with a COVID vaccine, which I'm not talking about the people that are like, oh, vaccine. They make vaccines to intentionally poison us to lower the world population or to microchip us or whatever. That's people that are like off the deep end. Which, if that were the case, I'm like, what takes so long to make a poison? Like, why isn't it here right now? Like, poisons are super easy to make.
I mean, but those ideas are based to a certain extent in some truth, right? I mean, this is the reason why A Handmaid's Tale, when it came out, struck people so profoundly, was that whole book, right, was based on individual things that had happened across time. Mm-hmm. It's just that in A Handmaid's Tale, they're all happening all at once. So,
I didn't watch the show. I heard it was very good.
Stuff and stuff before World War II, like real historical events that all get mashed up into one story. And so, like, there have been cases where companies have gone to India under the in cooperating with an NGO and have, sterilized people without possibly consent. Mm-hmm. So there's been things like that. There's reasons to, distrust. There's lots of reasons to distrust, corporations. Bhopal is a really good example of something that happened where, that company could have given information about what gas they were unleashed accidentally on so many hundreds of thousands of people, and they wouldn't do it, and lots of people died. There's lots of reasons to not trust big corporations, right?
Yeah. We all watched Chernobyl recently too. There's reasons that governments cover things. I mean, it definitely doesn't help, like, when you do find something that is effective and safe. All of that history does. Right. Like, look, we've had some light sterilization in the past. Yeah, sure.
Some things, man, but like,
moved past that.
Right. And there is a difference between Union Carbide and Pfizer. Like, these are these are different aims, different things, different companies. And I want to believe that most companies are not releasing massive amounts of poisonous gas on people and not saying anything about it, right? Like, I think that, but those events are so profound. Like, that's a huge event in my childhood. I remember that like it was yesterday. Mm-hmm. I thought that, as a kid, I just thought that was terrible. It doesn't help that Chernobyl happened not all that long afterwards either, with the same kind of like literal actual conspiracies, right? And I think that a lot of this doubt is based in that. But there are ways to front run against it. Mm-hmm. And when I was working in government, we knew that there was a growing body of people. There were people I worked with that were vaccine conspiracists. And so, there was, from my perspective, not a whole lot of effective public messaging early. Like, this is something that we could have gotten kind of ahead of in the 90s, and we didn't, and this is where we are.
You take something like Chernobyl, where it's a difference to say, like, mistakes were covered up horribly and perpetuated and led to more mistakes, and that, like, it was their intent to melt the place down in the first place to cause this and that. And those are two different things, but that's even more important to be aware of when we have from my view of looking at things, I think, when I put it out there to people what they wanted to hear about, a common question I got is, how much concern is there about rushing this thing? We have a global pandemic. Things are shut down. People are losing their jobs. They're losing potentially their homes, their businesses, their dreams. There's so much pressure.
Right.
And many people would take whatever vaccine is out there. How much do we have to be concerned more than your usual, say, like, flu shot or something like that, right, that things are going to be rushed and there's going to be mistakes made?
I think the biggest concern around this is probably efficacy. So vaccines generally Most of the vaccines that we get are either some version of a valent vaccine where it's targeting like a very particular protein or motif on Sorry, go ahead.
Could you maybe just do some 101 how a vaccine actually works?
Yes. So a vaccine, you can have, I'm just going to call them live and dead. So you can have a live vaccine or a dead vaccine. This is for the traditional vaccinations that you guys get all the time. I'm not talking about like gene therapies or things like that. That's different. And you could technically use the same term for them. So for the regular run-of-the-mill stuff that you get on the schedule, the options are live or dead. A live vaccine is what we refer to as generally as live attenuated. That means that the pathogen is alive and it's in there, but it's been bred to be either less virulent, like not going to hurt you, or like less likely to hurt you, or not going to hurt you at all, avirulent. And so an example of that would be polio. Polio vaccine is a live vaccine, or it's traditionally been a live vaccine. And then we have other ones that we refer to as valent vaccines. And these are vaccines that have one or some combination of molecules that have come from a pathogen. And then both of them, after that, have usually so there's a lot of water. Just to be clear, there's a lot of water that's usually involved. And then they have usually some other molecule that's in there that they know stimulates an immune response. So it's one thing to send, say, polio virus into someone, and it's another thing for your immune system to see it. Most of the most dangerous pathogens are really good escape artists. They've come up with all kinds of mechanisms that upon entry into your body, they start fooling and tricking the immune system. So one thing that is an important component for a lot of vaccines is a set of molecules that you know for sure the immune system's going to see. So they'll come to the location and, oh my God, look, there's this other thing here too. That's often something called 𝕊𝕠𝕔𝕚𝕝 that comes from the outside of certain types of bacteria. But it can be, there's chemicals that do it too. So there's a number of like just little chemical structures that people have made. And then you need to preserve it if it's a batch vaccine. So there's a variety of different tiny preservatives that are used. They're all pretty safe. And then you need to stabilize it. So that's separate. And we stabilize vaccines with a broad range of products called excipients. And excipients are often things like albumin. So you would be really familiar with albumin if you eat eggs in the morning, because the white of the egg is largely albumin. What albumin does in a body generally is that it keeps liquid things in whatever's holding the liquid thing. So in your body right now, your blood is loaded with albumin, and its main job is to keep your blood from seeping out of your arteries and veins.
Gosh, I love this stuff.
Yeah, right? It's the best stuff. So albumin is a commonly used excipient in vaccines. It's used for stabilizing, and it's usually human serum albumin. So it's collected from blood donations often. And so that's another story, but to keep most blood drive like organisms afloat, so like the Red Cross and any number of other companies, you have to sell off some of your product because most of it's going to spoil. And the longest that any given sort of blood component lasts that can still be donated to somebody is about 45 days before whatever nascent bacteria was picked up in the process, before it either dies or whatever bacteria was in there spoils it. So, So a lot of it has to be sold, and it's sold, albumin is a big part of that. It's sold in massive batches, like gallons and gallons and gallons and gallons, and then it's purified, tested, and then it's in your vaccine.
Do you so depending on your area, is that I mean, how does it all get to, because I'd be so worried. I didn't realize blood could just go rotten. How do you know you're getting fresh blood? There's just there's
regulations around how long it can last. So like the United States government under the Food, Drug, and Cosmetics Act has very explicit regulations for cells, tissues, and organs for how long that they can be held. What I was talking about was like fractionated, and I think red blood cells are the things that are kept the longest. But like when I've had to, for research, buy donated blood. And I get the leftovers that aren't useful to anybody.
The aftermarket stuff.
The aftermarket stuff. I get like what's the
bargain blood.
I get the imperfect, right? Like exactly like the bruised zucchini kind of stuff.
Oh wow! Like at the grocery store when they have all of the meat going bad, I
get the bargain basement stuff, the stuff that they can't put into somebody. So just because it's sitting too long, or in some cases I can pay more and get something that might have been, but in most cases I just get the bargain basement stuff that's not, Anyway, in those cases, it's 24 hours old by the time I get it. 24 to 36, depending, because there's overnight shipping, so 36 hours maybe.
If the whole work area behind you wasn't convincing enough that scientists don't have it made, you're working with bargain basement blood.
Yeah, it's true.
So, I mean, a couple things. All right. I had like 5 questions come up in that whole thing. So, one, when you were talking about how kind of sneaky modern pathogens are, and you study the evolution of the human immune system, do you think that any of the kind of sneakiness of the pathogens that take off have to do with just humans evolved to be these fantastic tool makers? We've stumbled upon this science stuff and germ theory and sterilization, and we've done things that do outwit a fair number of viruses and diseases, and perhaps that's changed kind of the regular evolutionary arms race between host and parasite.
Yeah, I think. So certainly the discovery of antibiotics has changed the evolutionary arms race between us and an awful lot of bacteria, right? And that bacteria are gaming a system that we happened upon, that they've been evolving for billions of years. Mm-hmm. And we found it and we're like, great, we're going to apply antibiotics now. And that's going to solve a lot of our problems. And we started applying them before we knew what we didn't know about them, which is that, they can be adapted to pretty easily. So I think the first mass market antibiotic is so they're discovered like ages before they're actually on the market. They're on the market in the middle of the Second World War, like broadly available. And then by 1950, there's evidence of resistance and broad resistance. It's being found in like cattle. So we've definitely shaped that, right? In that there's lots of bacteria that are gaming that system. Not only that, there's bacteria that really don't have very much to do with us at all, that are picking up the same antimicrobial resistance genes because we've done a fantastic job of mass environmental dosing. Some of these antibiotics that we commonly take, like tetracycline, have like environmental half-lives that go on for, hundreds of years. And then the other thing is that all of these bacteria can not all of them, but a number of them can pass like these genes horizontally, right? They can stick what's called a sex pili out of their membranes and plunge them into a neighboring bacteria, and it doesn't really matter who that bacteria is, and they can pass these genes usually in a small circular genome called a plasmid over. And then those genes may be incorporated or kicked out, who knows? But that has really important implications when it comes to disease. So these are all things that have existed for millions to billions of years, and we've found out about them because we started seeing resistance occurring. So that's one thing we've definitely changed. In terms of things like COVIDs, like coronaviruses, I think that's really hard to say.
Do you call them COVIDs?
I call them COVIDs. Yeah, because the short form, right, is COV. So if you look, that's why I call them. Yeah, I just call them Covies. And
you have a cute name for them.
That's really sweet. They're terrifying, but that's fine. Like
balances out those stress levels a little bit.
Well, I mean, there's a large number of them that aren't terrifying. All of us have had a coronavirus of one kind or another before now.
Many of them aren't pathogens for humans, right?
Yeah. So there's 46 species in total that are known. Mm-hmm. And the vast majority of them are not human pathogens. Most of them, though, are living in bats, which is pretty interesting. Good portion of them. But in terms of like stuff like that, what I was going to say is that our behavior and this is known from lots of different things, right? Our behavior is why influenza circulates every year. Our behavior is why HIV exists. And, the coronavirus is no different.
Gosh, I feel that when I emailed you, I was like, hey, could I ask you a couple of questions about vaccines? And now it's like becoming the whole episode.
Sorry.
No, I'm apologizing to you because I know this isn't really your thing, but I'm appreciating.
Well, it's not anymore. I haven't done it in a really long time. I am always on it to a certain extent. Yeah. And right now I pay pretty close attention to what trials are coming up. But I don't know how to describe this, but I guess once you're a policy analyst, you kind of always are. You're always looking at things from the perspective of like, how does this get approved? I regularly read regulatory updates. I just can't help it. But it's not what I do. I don't make vaccines. And I'm not involved in anything that has to do with their approval.
I'm usually pretty good about protecting myself from like little pop-up like Yahoo News stories and stuff. But I had one come up today. Something about some promising lead about plasma and antibodies or something or other.
Oh yeah. So this is actually, if there's something that we talk about that could be really important, I think there's a couple of things that we should clear out of the way about coronavirus. And this would be one of them. Yeah, so there's a desire for convalescent plasma, like plasma from people who have had this novel coronavirus. And there's been some early indications that you can help someone who has a severe infection by giving them convalescent plasma. That's a technique that's been used in medicine for a long time.
So when they already have it.
When they already have it.
I see.
So... But there's a whole bunch of things that we should maybe talk about that are connected to that. So I didn't read the Yahoo article, and I haven't read anything about convalescent plasma for maybe 3 or 4 weeks. So I might be a little bit out of date with that stuff because the way
it's a fast-changing world.
It changes. Yeah. So like I said, like right now I'm working pretty long hours. Ordinarily, I try to keep my work week down to 60 and below. But and one of the reasons why is that the info changes all the time. It's constant.
Yeah, but, I was like tweeting. I don't check the news much, and like one day I'm like tweeting like silly jokes about like Elon Musk or whatever, and then I get to the end of the day and I check the news, and there was like the George Floyd stuff was happening, and there's like a whole social uprising going on while I'm like tone deaf, like tweeting I've been having a pretty great day, and like
things are awesome right now. yeah things are moving fast. I mean, I'm hopeful fast.
Yeah,
I mean, it sounds terrible, but the more that we learn, and I mean this broadly, and I mean this like as a white person broadly too, the more that I learn. It shouldn't take someone being murdered for me to learn something.
Right.
But I mean, this is a time for us to be trying to learn as much as we can about all of the terrible things that are hurting us, right? So,
well, I think the coolest thing about all of this, if I can say that, is that when you stress a system, whether it's the human mind or the culture or government or businesses, a lot of the issues come to the surface, and that maybe some people were already aware of, but we weren't all aware of, and now we're all getting to see firsthand some of these social issues. We're all thinking about Geez, I never really thought about supply chain issues before, where my food comes from.
Barely say that I never once thought about how flour gets to the grocery store before.
So I think there's tremendous educational opportunities for all of us in many domains. And so I sure hope that many of us are taking as much advantage of that as possible. That's why I'm embracing this as much as I can, and rather than wanting it all to like la and just be normal, just try to take it for what it is and soak it all up.
I mean, it's one way of coping is to dig in, right? And so, which is, I guess, what sort of happened for me, because as giggly as I might be in this interview about this kind of stuff, and I'll laugh about the stress of it. It is like it's a dark time too.
It is,
because this is awful. But yeah, we had this conversation. I want to say that we talked about this a little bit the first time, which is that like pandemics change governments, right? Pandemics change things, and so something that, so this is just me being kind of an infectious disease geek, but one of the things I found super irritating about the coverage of COVID was there's a couple of themes that have really bothered me. And the first is that notions that like all this clotting in the microvasculature, the tiny, tiny arteries and veins, is novel. That's not novel. That's something that we see in sepsis all the time. That's a common symptom of sepsis. COVID often causes sepsis. Sorry, go ahead.
Why don't you talk about sepsis a little bit?
Yeah, sure.
Because it's what you do, and I remember you talking about it last time, and my eyes going like, "Oh my god!"
No, it's horrifying. So let's dig in. So sepsis is it's a profound immune response that is sparked by an infection of sufficient severity. It's a way of thinking about it is that it's a very, very severe infection. It doesn't particularly matter.
That's kind of the nerdiest way to say something really horrifying too.
Right,
what was that? An infection of what is it?
Sufficient severity.
Sufficient.
Yeah, that gives me a lot of space. For error, right? Yeah, but that's the reason why I put it that way. So it's an infection of sufficient severity that it sparks a profound immune response. Now that response, how we think about it, has been argued about. There are a number of people who think that maybe that response is in step with how bad the infection is, but there's also this broader group of people who believe that the response itself is this massive pathological response. And there's people that think about this in between. But regardless, what we know is that the immune system starts to is really engaged, and that this leads to what we call bystander tissue damage, meaning so the target might be the pathogen, but the response that the immune system is undertaking to take that pathogen out is big. And so there's lots of damage that happens to non-target items like vasculature and things like that. Mm-hmm. So anyway, clotting is a really important antimicrobial mechanism. Clotting is extremely important for capturing things that aren't supposed to be in you or trying to stop things from getting into you. And in severe infections, we often see lots and lots and lots of clotting. Mm-hmm. So that symptom is not unique to COVID. It's something that's seen in lots of different things. And one thing about sepsis that I want to be clear about is that the pathogen, it can be caused by any number of pathogens. It can be caused by bacteria, fungus, influenza, represents about 30% of the identified cases every year. It's also very hard to diagnose. That's another thing. People come into the ER, if they're really far along, they might get a positive diagnosis, but sometimes they get sent home. Mm-hmm. And it's fast acting and kills people quickly. The respiratory problems associated with COVID, the ones that require ventilation, like ARDS, which is acute respiratory distress syndrome, on non-terrible, horrifying pandemic years, about 50% of the cases of ARDS that come in to a hospital annually are caused by sepsis. It's a lot of this stuff is all stuff that we already knew. In terms of who's being affected, we've had 30 years of data that show that minoritized populations tend to be most affected by sepsis. In fact, the classic the classic person who is likely to acquire and die of sepsis is African American men living in urban centers. And it's been long assumed that that's because of inadequate access to care in one form or another. So we know all of this information. This has been known for a long time. And 750,000 people in the US get sepsis every single year. So it's not like it's not this rare thing. It's exceptionally common. And so we've had this information. It's been known. What a good thing that's coming out of COVID is that now everybody has to digest this, right? It's attracting so much attention that people really have to contend with it. And why those populations end up with sepsis is complex. But every investigation that I've ever read that looks into some sort of intrinsic genomic reason, like it's in their genes, man, it's not a genetic phenomenon. It's never been. No one has ever found a target in the genome that I've read, in any case, that has segregated along identity lines. It's something that's the outcome of being. Being a population that's more likely to have these comorbidities, and these comorbidities are often environmentally caused.
Yeah. I mean, this was the first thought that occurred to me when the protests started that I had, and this might be an uncomfortable conversation, but this is a good time for uncomfortable conversations. My first thought, as someone who was like, on one side of things, very excited, as someone who like loves raging against the machine but also spent months talking with scientists and infectious disease people about scaring the crap out of me about COVID. I was like, well, I know this virus doesn't discriminate, but I know that our healthcare system and our housing system and everything does. And I know minority groups are going to be the most vulnerable, especially if you're in a group of people that, say, are less likely to have a separate bedroom to quarantine someone if they do get sick and things like that. And I thought of, like, that was my first thought as soon as and I don't think that this thought was lost on a lot of people, of what happens when you start putting a bunch of people together, and you know, plenty of white people protesting too, obviously. But what happens even if it was a grand experiment, even if people are seemingly wearing
wearing masks and,
quite a bit.
I mean, I think one of the interesting things right now is that we're seeing a huge uptick in cases that are stemming, very clearly mapping to the July 1, July 4th holidays that just happened in North America. Yeah. And additionally, I don't know if this is true. I meant to look at the Quebec numbers. There's a holiday in Quebec on June 24th, Saint Jean Baptiste Day. That is also a prime time for gathering and things like that. We're seeing upticks from that. We're not seeing upticks from and there's been a lot of analysis around this. We're not seeing upticks stemming from the Black Lives Matters protests.
I mean, that's shocking to me, just in terms of my understanding was that masks don't mean you can stand right next to somebody.
Right.
They're lowering the spread of droplet.
They certainly don't. But there's a difference between how these events are happening, right? Yeah. So like the backyard barbecue, if everybody's back in the backyard, sure, but people go in and use the washroom, right? At these protests, people are not indoors, they're outdoors. So that automatically lowers the threat of acquiring something from an aerosol, which is tiny. The masks are supposed to generally catch droplets, which are, I can't remember the exact size now. I used to know this off the top of my head, but are substantially larger. Sorry, it's just stuff that you know.
You don't know the droplet size? Come on.
It's like less than 5 nanometers, or more than 5 nanometers.
I thought I was interviewing a professional here. Yeah, how do you not know the
scientist, am I right? Like, yeah. No, it's true. It's and then aerosols are less than 5 nanometers, and then the virus itself is like 0.125 nanometers, I want to say.
And
anyway, it's considerably smaller than an aerosol. So So the masks, no, they don't. And especially cotton masks don't stop virus, but virus is being carried around in liquid. And so it'll stop it if it's in liquid, which it is most of the time. The other thing too is that like, it's easy. I think that in social gatherings, it's easy to not be as safe. Mm-hmm. You can let your guard down. Protesting requires even in normal times, requires a bunch of safety mechanisms be in place, right? Mm-hmm. A lot of people write down their phone numbers on their arms in advance. If they're pregnant, they write that down, they're
not protesting science. So they're not protesting like washing their hands and these other things that other people might not be taking seriously that are going like, I'm celebrating the 4th of July, damn it, because this thing's a hoax. Those people might be more likely to not wash their hands after using.
Well, the other thing, too, is that where I am, so, and I think that this might be true of a lot of places, I'm kind of right now in this rural college town where we haven't. No, I'm in Illinois, so I'm in like central Illinois.
Okay.
So where we haven't been hit too hard as far as we know, right? We haven't had an overwhelmed ICU. Things have been handled pretty well. Our case number for identified cases is pretty low. And under those circumstances, having been isolating a long time, it's easy to convince yourself that it's not that dangerous. It's not that big of a deal. Mm-hmm. So, and nobody I don't know that any of the gatherings where this stuff is happening, I think there's maybe a lot of it's going to be by accident. I think some of it also is like skewed risk perception, like rationalizing, for example, like the original information that came out about this virus, right, from the original cohorts was that it's killing people that are over this age, right? So the people who are most likely to die are going to be over the age of 65. There was weird interpretations of information around whether or not children could even get it. Like, or how responsible they were going to be for like trafficking it from one person to another. And I think those early messages kind of held, and it's easy if you're sick of being at home to rationalize, okay, well, it's not going to be that big of a thing. Mm-hmm.
And it's my understanding that there's no evidence that any single human is less susceptible to getting it. It's just what happens after you get it where there's the individual differences.
Right. So it's definitely progressing in people differently. I haven't seen any information suggesting resistance, period.
Yeah.
Like meaning that you get exposed and you cannot catch it. Mm-hmm. I've not seen anything. In fact, I've been digging through a lot of coronavirus literature and I haven't seen anything on resistance. And it could be that I'm just missing it because there's a lot, but I haven't seen anything on it. So it's an issue of what happens after the fact. And that's important too. How much you get when you are first infected probably determines quite strongly how you progress. So even if you were going to think about people who are immunosenescing, meaning that their immune system is aging and therefore is regulating differently, there's strange things that happen to you after the age of 55 or 60 where like you don't produce T cells in quite the same way. Weird stuff. Anyway, it's not uncommon, for example, for people over the age of 60 to not readily develop a fever when they're infected with something that would easily develop a fever or lead to the development of a fever in a 20-year-old person. So there's this issue of progression and what symptoms show up. And then there's just an issue of whether or not someone recognizes they're sick as a result, right? So there's all these things that play into it. I haven't seen any evidence of resistance. What I have seen from the beginning is misconceptions around treating this virus as if it's somehow inherently special compared to every other coronavirus we know about. And other coronaviruses transit between children all the time. Mm-hmm. If they didn't, then people with kids in daycare would be leading much easier lives. Yeah. Right? Like that's just how it is.
They always have a snotty nose.
The other thing, yeah, exactly. And this brings me to the point that I wanted to make around antibodies a little while ago, and I think it's really, really important. The information that we have right now on SARS, which is the 2003, 2004, well, technically 2002 to 2004 coronavirus that led to outbreaks in China and in Toronto and a couple of other places. I shouldn't say a couple. It actually is quite a few other places. I think it's 26 countries. But the point is, it was a coronavirus and it was called SARS. That's the most closely related thing to SARS-CoV-2 that we know of that's in humans. That whole family of viruses, which falls under beta coronaviruses, and there's a number of them, including Middle East Respiratory Syndrome and virus and a couple of others. The antibodies that you raise up against these things, this specific group of viruses, at least for SARS and for MERS, drop off precipitously after 2 years. So that implies that the B cell population that, just to be clear, B cells are what make antibodies, that the B cell population that recognized this virus when you were infected and then made memory cells to stick around, those memory cells are either malfunctioning or dying off. Mm-hmm. They die off by year 3, they're gone. You cannot find antibodies after year 3. So for everyone who's getting infected right now, it's I've got it, I'm good for life. Probably not. It's a slowly mutating virus and the antibodies die off really, really fast.
Well, I mean, there's definitely that's kind of good news if it's a slow mutating virus, though, right? In terms of the other side in terms of making a vaccine for. Yeah,
so that's a relative term, to be clear. I'm thinking about it in terms of things like HIV. It's very, very slow. We'll have a better sense of how quickly it's changing. We have a nice sense right now, but we'll have a better sense as years go out. Yeah, I think so. I think there's a bunch of different vaccines that are going to trial right now. And they use a bunch of different techniques to get around this issue. So the first is I was just checking out today. So if everybody wants to feel a little bit better about this, I can't say how many are vaccine trials, but the number for what has been registered as a clinical trial in the US and in 216 other countries is something it's over 300,000. It's 345,278 as of today.
That's the number of what?
Clinical studies that are underway, and that means clinical interventions. So a vaccine, let's try to save this person who's in distress, stuff like that. In some cases, they're looking just at molecules to put into vaccines, but yeah, 345. And that's all stuff that has been the vast majority of that is stuff that has been done and achieved in the last 4 or 5 months. So in any case, there's a lot. Some of those are vaccines, and the models for these are vary. So this issue about whether or not it's going to mutate substantially over time makes things like valent vaccines, where you're looking at protein chunks, and you're putting those into somebody, and then they raise up a response against it, and then you're protected. That makes those potentially a little bit risky. However, there's every reason also to think, based on what we knew even a couple of months ago, that there are good targets on the outside of this virus that you could use for this kind of vaccine. And so there's a bunch of those that are under consideration. For that kind of vaccine, if it is successful, then I would think, I don't know, but I would think that you might still face the same issue of antibody titer drop off. So you'd be looking at a regular vaccine schedule that's happening every couple of years, maybe. It depends on how, you really can't say anything until you have the trial results and but that, based on what we know so far, I think that might be the case. Then there's a couple of others where so one of the more complicated ones, there's a couple that look like this, and Moderna, which has gotten a lot of attention, is proposing something similar, where you make human cells make the RNA of the virus, and then that necessitates that then it's being made inside of you, and the immune system sees it and says, hey, this is a problem, and therefore it sparks a response. And I think the idea is that would be constitutive, meaning it would go on forever. And so one of the ones I was looking at involved using So it's very funny the way they worded it is an efficient lentiviral vector, which probably means an HIV-like virus that they've chopped the bad parts out of. And then they put this code in for this virus, some section of this virus. And then what you do is you continually make this virus protein, presumably to the end of your days, and your immune system keeps seeing it. And therefore it keeps making memory against it. I think that's the mechanism. Anyway, it's very complicated. There's a lot of them anyway.
When someone gets it now, my understanding is that there's been cases where people have gotten COVID-19 and not produced antibodies.
Yeah, I'm a little bit more out of date with that than I should be. I've heard a couple of different things that I haven't been able to chase down. And one is that there is maybe a less than lustrous antibody response. Another that I've heard is people getting repeatedly reinfected in short order.
That's the scariest possibility, right?
Right. So what we have to remember is that when people are looking at these things, they're relying also on tests, sensitivity of tests and timing, and appropriate sampling. And so when the first stories came out about this, they were out of China, and the authors themselves had concluded that this probably had to do with people, either the sensitivity of the test or people actually having had it and the test not having revealed it for some reason or another, that it wasn't sampled correctly, or that these were people who were really positive the whole time. In terms of the antibody response, it's harder for me to comment on that because I haven't read that much about that. But I would say that every single time you read about this, you have to keep in mind that these are all newly developed technologies. Some of them are well-worn. Like the test itself is a well-worn technology. It's been around for a long time. They just changed small pieces of it. That's also true technically of antibody testing, but it's important to keep in mind that there can be errors, and the way. So one of the things that's really important, I think, also to emphasize, is that the major publishers for like journals, for academic journals, have recently come to an agreement that, or at least a number of them have, that you have to deposit your paper that you're going to submit to them in a public archive first before it's peer reviewed. So it goes to a place like bioRxiv or medRxiv. And what that means is that a lot of stuff that hasn't been frisked, even though it's probably very high quality work, it hasn't been frisked, and it's sitting by other scientists, and it's sitting publicly available. And the reason for this was to say, like, hey, everybody who's discovering information about this should have it available to them so we can come to a solution as quickly as possible. But what that means is that often then it gets picked up and carried to the public without context that other people, like other scientists, could bring to the table. And so I see. So I think that some of these stories around infection and reinfection, I always try to think about that, even though I can't necessarily get on it. Well,
because there's that, and then there's the idea of, I think the other big important one seems to be what are the long-term impacts if you get, some people recover and they're maybe 100% afterwards, or are there long-term lung problems, other issues that I mean, obviously we won't know for a while anyway, but do you have a sense?
Do you want to hear something really depressing?
Yeah.
Okay, so since our last conversation, remember our last conversation? I'm
glad that the world's finally caught up to the depression that I've felt my entire the world's caught up to how I've felt for 30 years.
Right, the overwhelming existential dread. I totally get that. I feel it. I do. I feel like also finally the world is caught up to my overwhelming paranoia about microbes. So we're here in good company. We last spoke, I want to say, maybe 2 or 3 weeks after the shutdown in Illinois, which would have been pretty close to the shutdown in Wisconsin. You were like, so, what's going on next month? And I was like, oh no, man, this is a year-long thing.
I remember.
I'm in my lab at the beginning of March, and
I didn't book a single gig after talking to you. I've been offered gigs. And they're doing they're doing socially distanced comedy clubs.
Are they?
Worst idea. There's already been someone fainted on stage. And tested positive afterwards. So then they had to like test everyone in the showroom. And then there's been two, very, very recently, two fairly like well-known, fairly popular, comics with big podcasts that have been anti-mask, anti-everything, went touring.
Wow.
Them and they were doing meet and greets after the show, taking pictures with people and everything, which even if the club itself was distancing, that eliminates the whole point of distancing. They and their two people that they brought with them all got it. One of them was a cancer survivor who got in rough shape from it. And so I don't know how many people in the showroom ended up getting it. I know of 4 people that were in that showroom, and 100% of them have gotten it, and so it's just
that's awful.
Yeah, and
that's really awful.
Yeah.
So
I've been trying to be like, what are we doing? First off, it'd be like a socially distanced jazz room or something like that would be like a really cool experience.
Yeah.
Socially distanced comedy just simply doesn't. That's like the list of things that you need to do to make it safe is the same list of worst ideas for a comedy show, and so it gets into the why bother sort of.
People need to see social cues, right? Like laughter is literally a contagious thing.
Yeah.
Right? So here's my depressing revelation. It's the context for this is based somewhat in the antibody titer discussion that we just had, and then also so I think a vaccine is going to come to market sooner rather than later. I actually think the vaccine is going to come to market on the schedule that we talked about the first time, which is the reason why I said things were going to be shut down for a year. I said that I thought that at that time that it would be reasonable to expect that a vaccine will be on the market sometime between January and February. The issue, there are several issues. You want to have a lot of vaccines. The second, like a lot of different kinds. At least if you have one approved, you want lots of different people making it. There has to be a lead up time for distribution. So for the flu vaccine every year, there's a 3 or 4 month lead up. So you would expect that too. And then the first people who are going to get it are going to be the people that are most likely to be exposed and are in essential positions. So there's all of that. So then you're looking at a distribution lead time, 3-4 months. There's issues around costs and post-market trading. And so I would expect that people like you and me, if it comes to market in January, probably won't get it until June. Now,
what if I get like a bigger following and I'm more famous?
You're more famous and more essential. So yeah, maybe, but maybe it's earlier than that. I don't know, but I'm just like sitting right now thinking it out. Let's say the worst case scenario is that if it is approved and ready to go and hitting the market in January, February, that the rest of us are getting it over the spring and summer. Okay, so if that's the case, the virus itself. So the R naught values, meaning the number of people that you're likely to pass it to, who will actually acquire it, differ by location and things like that. But they've never been less than exponential, meaning that it's always been calculated that one person will pass it to at least 2 on average. The higher end of that is estimates up near 6.5 to 7 people that one person will on average pass it to 6.5 to 7 people. And like I said, it depends on where you are. There's a lot of like social factors that go into this, but it's never been less than exponential. At an exponential, now I'm taking a page from someone else's research, so I don't specifically do this. But my understanding is that at an exponential rate of transmission, you need high levels of herd immunity. So, and I mean high, like 60 to 70%. And then if it's as high as 6.5 to have effective herd immunity, you need to have much higher than that. That could be as high as 80 to 90. So, the work that was talking about this and throwing these numbers around was published in April. It could be that views have changed. I haven't seen anything that suggests that the view has changed, but that's really high. So for worldwide, you'd have to have a vaccination program that hits hits that many people. Mm-hmm. And then you're going to have to, maybe if antibody titers drop as we think they do, you're going to have to come back within 18 months and do it again. So it's presenting a bunch of challenges potentially. Now, that said, we don't have antibody information on this COVID yet, right? So maybe among beta coronaviruses, it lasts longer. Like maybe our B cell responses, we're going to find out that they're longer running and that the antibody titers don't drop off. If it's anything like SARS or MERS and a number of others, then they will. And so, but like I said, it's possible it's not. But in the worst possible case scenario, I think that we're looking at strange modifications for maybe 3 years. So that's my depressing scenario. And then you asked about what's happening health-wise. So given all of that's a possibility. Mm-hmm. But even if it's not, in what we call posse-symptomatic, so people who have like low symptoms, they often get called asymptomatic. So people who are either thrown into one of those two categories where they don't know that they have an infection or they have mild infections, there's already evidence that they have longer term issues. So at least within a couple of months have longer term issues. So for example,
within a couple of months.
Yeah. So within the months that we've had to look at this, there's already people who show up who are posse symptomatic or lowly symptomatic. And when x-rays are taken of their chest, they have those same evidence of viral pneumonia. So they're not expressing symptoms the way that you would expect, but they have viral pneumonia. And they test positive for COVID-19. So it's an x-ray image that's called a ground glass opacity. It's a very specific kind of image. So that has implications for what happens in the years out. We know there's recent reports around potential problems with neurological function, even in mild to moderate cases. I should probably get something else out of the way real quick. So just to be clear, SARS-CoV, so COVID-19 as a severe infection is severe pneumonia requiring ventilation, meaning you have to be on a ventilator. And if you're on an ventilator, most of the time that means that you've developed ARDS, which is acute respiratory distress syndrome. That condition is caused usually by some kind of clotting or inflammation that leads to like plasma leaking into the lungs. So fluid comes into the lungs from the blood supply. That fluid, the plasma, contains a bunch of factors, immune factors that go ahead and start knocking out what's called surfactant in the alveoli. Surfactant works kind of like the grease of the alveoli. It's really important for the expansion of these air sacs in the lungs and then their deflation. And so in the absence of the surfactant and with all this liquid coming in, the air sacs have problems doing what's called recruitment and de-recruitment, meaning that they start to slow in terms of how quickly they open and how well they close. So this is why it's really depressing. So on top of that, also there's these other immune factors that are coming in from the blood that are sitting in the lungs too. What this does in combination is two things. It means that the reason why you're on the ventilation is because you need to have more pressure and more time to open the air sacs in the lungs. And that's why things need to be ventilated. But because all this other stuff is in there and the process of ventilation itself is also dangerous, you can do damage to the lungs doing it. What often happens after ARDS resolves, if you survive it, is people develop lung fibrosis. All this damage has to be repaired. And in the speed of repair, a lot of this crap that came in with the plasma is just woven right into the lung tissue. And so there's this longer term issues around breathing. But people who develop ARDS are also 5 years out more likely to have neurological issues. Having severe infections often leads to muscle wasting at the time. That muscle wasting often goes on much longer than that for a host of reasons. There's post-traumatic stress disorder from simply just having it. People who develop sepsis, period, are more likely to die of any cause mortality in the next 12 months. So there's that on the severe end of things. Then there's the next category down is mild pneumonia, which is a huge category because for anybody who's had pneumonia, they know that doesn't require ventilation. They know that it's pretty serious. It could require oxygen supplementation and you would still be called mild pneumonia in the current way that COVID-19 cases are broken out. Then there's mild, which is anything that's not mild pneumonia. And then there's asymptomatic, paucisymptomatic, which is something where you may not necessarily know that you have the condition. And that's a really tricky category because there's no cohesive set of diagnostic cues for anything other than the most severe cases, like the mild pneumonia through to severe pneumonia, that you have this in the first place, other than say like a positive test. So there's these big, big categories that people get lumped into, and all of them, even if it were regular run-of-the-mill pneumonia, you would expect to have longer-term ramifications around breathing difficulties, likelihood of getting another infection down the road. The troubling thing about these uncoordinated symptoms that are mild is that now we're getting evidence that there are longer term issues, like ground glass opacities imply that there could be issues around breathing that'll happen later on. Just because that they have viral pneumonia and you would expect that. People lose their sense of smell. There's all this microvasculature issues. So recently
that's those bros. One of them's like an ex-MMA fighter, so they're like a couple tough guys that were anti-maskers. Their poor friend that was the cancer survivor, they're already like, yeah, he's lost his sense of smell and taste.
Yeah, and that's so one of the things we know about coronaviruses is like some other viruses, a number of them are known to jump the olfactory bulb. They're up in the nose anyway, and the olfactory bulb has a bunch of adaptations to prevent this from happening, but what is that thing from Jurassic Park? Life finds a way. Find a way. The CNS is a great place to live, man. If you can get in there, you're looking at down-regulated immunity and just so many cells that you can use. And so we know that they jump in, and we know that they can also spark cell death. So there's reasons to think that there might be long-term neurological things. And recently this week, news broke that there are people who are suffering from clumsiness. Now, like I said, some of that might be from clotting, right? So it could be that people are suffering infarctions, but it also might be like neuronal cell death that's stemming just from the infection itself. Nobody knows. The thing that I find most troubling about this is that we might be looking at a really big shift in what health in worldwide, but in the United States looks like, right? That people will have these sort of longer term things. So one of the projects that I'm working on is trying to figure out what those are. One of many that I've been pulled in on is looking at okay, this person presented as asymptomatic. What does health look like for them 4 years from now? So I don't know. We'll see. Yeah, that was depressing. And you know what the thing is?
Fast. You know what the most depressing thing is that I'm keeping you way over your time because I want to talk to you for 2 more hours about this.
I know. I'm sorry.
You want to do this again sometime soon?
Yeah, let's do, because certainly the situation's going to change. I mean, it changed even today. I'm sure I'm just behind by a couple of hours.
Yeah.
On some topics, I'm deeply behind. So,
Me
too.
Sure.
Let's do it again. I just really quickly want to say that.
But I have at least 20 minutes. I'm just being mindful of your time.
Okay. Yeah, that's totally fine. This apocalyptic scenario that I've just sort of drawn out, a lot of it's based on information that we have about other coronaviruses. Mm-hmm. The bottom line is we only know what we know, and what we know is not as much as we need to know. And so this is my impression right now. When you and I spoke in March, my impression was different. My impression was this is going to be a year. There are easy targets for this vaccine. There are, I don't know, if a valent vaccine will work, but yeah. So my impression is different. And if we talk again, like 3-4 months from now, it's going to be really different.
So
again.
your impression is worse than when we originally talked.
More complex.
More complex.
Yeah. What I want to emphasize is that there's a lot of research happening. Everybody, like I wasn't studying coronaviruses before now. The last time that I dealt with the coronavirus was in 2003 during the SARS epidemic. And when that happened, someone came back from some high-level meeting and mentioned to me it's a coronavirus. And I was like, what the hell are you talking about? Don't those cause colds? And that was like, it was stunning to think that this kind of virus would do something so terrible. And then I went on to study other things. I mainly poke at plague all day. But everybody who has any expertise in infectious disease or even just infections or even, I don't know, like everybody has some level of expertise that's important here. Short order cooks have that expertise that's extremely important here in terms of like providing food to people and what sort of safety things need to be undertaken. And I'm getting yanked into this because there's a need for bodies. And so, everybody's throwing some weight behind it that I know of. So I would say that like things are moving, and anytime we get new information, that's good. So keep hope, because it's not necessarily as dire as I just drew it out. I just wanted to make clear that there are these challenges.
Because it's just like a whole conversation of everyone's going to be like, well, what do we have to do? We got to go back to work. I guess we're all just going to get it. Is like a lot of the sentiment right now of just like, well, we can't shut down school forever. We need healthcare, everything else. And so. True.
But like what we just talked about here, where you were talking about like how comedy clubs have to run, like what's the service to comedy versus like what's safe for people.
Yeah.
That stuff that like, so, everyone could write a risk policy. Every single person could write a risk policy based on their expertise of what they do. Yeah. And so, that's good. It's just an issue of people getting the right information. And one of the things, I'm not trying to be in denial of the fact that there are a lot of people in the country that are willingly throwing off recommendations. It's more that I think if we work to educate as many people as possible, then those people will become the minority. Nobody wants this.
Yeah, right. I mean, do you think that there's possibilities in the future of having a more instead of a broad, because as things are spiking again, I see kind of a nationwide lockdown, everyone kind of maybe going back to the lockdown that we had, rather than, in an ideal situation, we would have essential workers and then put policies in place that we can expand what we consider essential workers, and then have enough policies and enough precautions. And now we've adapted and we're all wearing masks, hooray. And then we have service industries that serve essential workers first for their mental health, and like slowly and cautiously expand things as we know more and we have better practices in place. And if people aren't, because part of the I had a socially distanced 4th of July with a few people, one of them being a aunt of mine who was like, well, they shut everything down and then nothing happened because this wasn't anything. And it's like, no, we wish nothing happened.
Right.
If we would have shut that would have been the point.
Right. We could look like Canada, right? We could look like other nations that actually did this.
And my understanding is that more people than projected in the U.S. actually did follow stay-at-home policies, and that's why numbers were lower than some people were first projecting that they would be. And so anyway, if we're talking about something that might be 3 years, would there be something in place where we're looking at area by area and you're having like some sort of algorithm developed based on number of ICU beds available, number of how well equipped an area is based against population density? And so obviously all the metro areas are going to be, potential epicenters. But what happens when you're in a city of 40,000 people? What happens when you're in a town of 600 people? How much do you have to shut down?
Right. Do I see there being national coordination? Well, we had a response team that was let go in 2018.
Yeah.
So I think if you want to see national coordination, you need to see a bigger change.
Yeah.
My fabric mask, I have a couple of fabric masks, but the one I wear most often just says vote on it.
Yeah.
I mean, not to dismiss the fact that there's been efforts to ensure that certain people don't vote, but right. So all of that stuff aside, I mean, if you want to see the change you want to see, you're going to have to put people in charge that are going to do it.
Yeah.
One thing I would also argue is that if you really want a nationally coordinated response, you need to make healthcare accessible to people. The way that this pandemic response ended up working was with very little national guidance. And so there's, state governments have had to hustle in a way that they wouldn't have had to. And like, for example, the testing in my town was set up and run by the university. And it wasn't even like the university did it. It was like 5 scientists got together and like, do you have the appropriate equipment for this? Yeah, I've got some. Do you have some of these plastic trays? Yeah, I have some. And they went over to the hospital and were like, here it is. Here's what you need. And we'll make the viral transfer media for you in this lab of ours over here if we can get the supplies. Like, that's how it was done. And members of the junior faculty at my university have been the people who have been really important in guiding the state's response. And that's great. But in an ideal scenario, you have national leadership that tells the state governments what they need to do. And the state listens and says, okay, you know what? This is a huge pandemic. This is a real problem. And we're going to follow the recommendations of experts. They don't have to go, rustling bushes or have people rush to them and say, let me help you. That's the first thing you need is a coordinated national response. If you want to coordinate a national response, you're going to have to vote for one. The second thing I would say is that access to care. I'm repeating myself. Access to care. Honestly, the bigger issue, I think, overall, is that you're seeing people die at an uneven clip in unfair ways because you don't have a national healthcare system. Mm-hmm. Well, technically you do, I guess. Right? You've got Medicare and Medicaid. Mm-hmm. But honestly, if you want that, which characterizes a lot of the other countries that have been more successful, and I'll say something else about national healthcare systems. They come with an attitude of national cooperation. Mm. So that's a nice side benefit if you want to crush a curve.
Right.
So if you want that, you're going to have to vote for it too. I'm not sure that that's on the table, but you want it, put the people in charge that you want handling this thing.
Yeah. Yeah.
And that's at every level. The counties have to take their, have to accept the money that the state gives them, and they have to accept the decisions that the state makes. So, in some places, the surveillance has been taken out of the county's hands. They're just getting reports from the state, and it's being managed entirely by the state. In other cases, you want to get to, minoritized populations, you're going to need the counties to have the power to go in and set up testing in regions that are, have poor access. So, this means voting at like every level. You guys have these epic ballots. These are the things that need to be filled out to make change.
Yeah, I guess I just wish there was like I would much rather, for all of people's fear of like the singularity or the Terminator taking over, I would much rather have an algorithm to look at, like, here's your area and here's who's at risk right now, rather than what policy are we going to have? Well, is my governor red or blue? Because that determines whether I never go outside again or if it's spring break in Myrtle Beach or whatever.
For reasons that I think we all know, the pandemic's politicized, right?
Yeah.
Even the flu season every year is politicized. So not as much, clearly, but like it is. And so I think if you want an algorithm that's using like great minds and is being managed nationally and helping states locally, you can't not have people in charge that are not going to dismiss large sections of the CDC, right? Mm-hmm. I've used the word not in there a lot. You need somebody who's going to preserve pandemic response teams in the CDC. Yeah. That's the branch of government that's responsible for this. Like we're all listening to Anthony Fauci, right? Mm-hmm. Everybody's, but Anthony Fauci's job is to manage research funds out of NIAID at the NIH, out of the National Institute for Infectious Disease or Allergies and Infectious Disease. He's certainly deep in research and he's a practicing MD. Like he's an incredibly knowledgeable person, but he's the lead voice here when it should be the head of the CDC.
Yeah.
So things are backwards and topsy-turvy, and Anthony Fauci has like such great expertise, and he's navigated so many things. Like I trust anything he says. I believe, like I fully trust him. So I'm not saying this against Anthony Fauci. I'm saying that there should have been a large team in place at the beginning, and we don't have that because they were fired, and not fired, but they were disassembled. They were disassembled because the last big thing they had focused on had been Zika and Ebola, and that was seen as a foreign disease. What do we need this for? Ebola someplace else. So if you want this, you want a nice algorithm, you're going to need, and there are algorithms that are out there. I mean, people are developing things that look like this, but if you want it and you want it at a national level, you got to have people in charge that are going to like respect the science.
Mm-hmm. Well, that's terrific.
That's a depressing story.
No, it's not. I mean, I'm not hopeful for that. I mean, look, I have a science podcast. I do everything I can to dump money I don't have into getting the things you have to say and into getting it out there to people. Well, so
I want to say, like, look, voting is an important thing, but for me, and I'm not saying vote one way or the other. Yeah. I'm saying empower your neighbors to vote. If you want this gone, you need to empower people to vote leadership that's going to make a change, even at the smallest possible level. So if you do one thing, not you, because you're doing a great job at just getting word out and stuff. So I'm not saying you're not doing something. I'm just saying, like, if anybody were to do one thing, it's to empower your neighbor to vote, whether you agree with them or not.
All right, you heard it here first, people. Anti-Fauci activist Jessica Brinkworth is saying that voting's a good idea.
Honestly, he's on my list of people. He's for ages has been on my list of people I want to meet. I was going through, so I don't know. Do you have a celebrity list of people you desperately want to meet?
Scientists are my heroes, and I kind of do. I get to talk to. I don't know.
Oh, you're lucky.
I had when people are like, "Who is your?" Robert Sapolsky was my guy.
I definitely made him late for a plane once.
Yeah. I don't blame you. And I have more. I have some people that I would like to. Yuval Harari. The Sapiens, all the rage. I don't necessarily agree with all of his stuff, but I was, as someone who was like a hipster, I took his class online before any of his before Sapiens, which is his first of 3 books, came out, and I was like, who the hell is this guy? Like, such an incredible communicator. And then to see his books like take off, like, I haven't seen anything happen since like The Selfish Gene or something, has been kind of incredible.
So my list has been revised a few times, but my list as it stands currently is Anthony Fauci has long been at the top of that list. Since I was like early grad student, just thought, wow, this guy's got the coolest job. In fact, And also because I was a little HIV obsessed as a kid, like I was kind of a pill as a kid. I was really aware of really terrible things that were happening in the world and like really frustrated that I couldn't do things about them. So he was on the news all the time. Mm-hmm. And when I was a child, but what was I going to say? Yeah. So he's long been on that list. And then Raffi, right, who's a Canadian children's singer. Who I forgot about.
I was like, is that?
Yeah. No, I mean, literally Raffi is on my celebrity list. And then Robert Sapolsky was on the list, but then I met him.
Yeah.
Which he was wonderful. He was really nice, but therefore he's no longer on the list.
Yeah, I don't know that I have.
And Peter, another one, Peter Staley, who was the head of ACT Out. Or ACT Up. ACT Up. Sorry. Yeah, that was another person that I really wanted to meet. I think that there's a really interesting intersection for activism and science that like he has been at the center at for a very, very long time. And he's pals with Fauci. Here's what I was going to tell you about Anthony Fauci, and then I'll let you go because we're literally at the end of your time now. So
this is amazing. This is the longest episode of the Here We Are podcast ever. And I want to have you back on again as soon as we can make it work.
This is the Jessica Brinkworth chat hour.
Yeah, it's been great.
So I had a student who was in a class, someone else's class, where they had to write some professionalization class where they had to write a letter to somebody who had the job that they wanted to have. And this kid wanted to be a public health official. And he had written to the head of the Champaign health department, but like accidentally in Ohio, and had a nice conversation, but was feeling like he hadn't really gotten the information he wanted. And I was like, well, what kind of stuff do you want to do? And he said that he wanted to be like in like one of the security investigators in and around emerging infectious diseases. And I was like, so then why are you messing around with like local government? Why don't you write to Anthony Fauci? And he was like, how do I find out how to do that? So I looked up one of his papers, and where he was like the author of reference, took the email, gave it to the kid, and was like, write to him. So he did, and Fauci responded by the end of the day. Wow. And said, and it was through like an administrative channel, and said, write a list of questions for me and I'll answer them. So this kid wrote a list of questions, and then he asked me to look at them, and they were fine questions. But then I put in a question of my own. Yeah. And so, and he answered it, he answered everything, and very completely, like it would have, for me to have written this email would have taken at least an hour of my time. We got the response on a Sunday, and it was this really earnest, honest response about how he had gotten the job, why he was interested, his path there, the problems that he's had in the position. Like, it was such an earnest and encouraging email that I was just so completely fulfilled that my student had gotten this response back, and he answered my question, which was even better. So that might be as close as I get in my career to ever having a conversation with him. But it was
I'm going to get to Fauci, so and then I'm going to get you to Fauci.
Yeah, you get to him, and then we can talk. Yeah, because me fangirling here won't be awkward at all. But anyway, he was very kind and extremely giving of his time. And I was just, if a kid had written to me on a Friday, I would not be answering those emails on a Sunday telling him the path of my career, right? Like I just would have I would have been like, whatever, we'll wait till a Monday, or I'll get to this, right? But he was just so on it and so kind about it. So yeah, anyway.
Amazing.
Yeah, well, he seems like a nice guy.
Well, I got to go write a letter to John Malkovich real quick, so I better get out of here.
Are you for real? Really, you're gonna?
We're talking about writing letters to our heroes.
No, like your work is very different than mine.
I do. I mean, he seems like odd but personable as far as eccentrics go. So take a chance. Write a letter to Malkovich or Fauci, everybody. All right, Jessica, thank you so much for joining me.
Thank you for having me.
I'll put your link to your work and everything. I'm still figuring out my new YouTube channel and everything.
Oh, that's really fine. I have a paper coming out. It's kind of dense. I have a paper coming out in September that talks about the evolution of what's called cell autonomous immunity. So it's meant for sort of a general educated audience, but it talks about like how humans, a lot of the mechanisms that we use to fight infections are billions of years old, that they have more to do with our single cell ancestry than necessarily modern ancestry.
That's amazing. Evolution's more my jam. I'm just trying to wade into the waters of this vaccines and things going on right
they're
now.
all connected.
Yeah. So awesome. Well, and I'm getting my website. I'm getting a whole new website. It's under construction right now, but I'll have it all nice and designed and navigatable for people. So send me your paper. And thanks for joining me, and thank you listeners for being such a wonderful, curious audience, and we'll see you next episode. Thank you guys for watching. If you enjoyed, please hit that subscribe button for new episodes, highlights, all that great stuff. Putting up some old highlights of audio versions. Going to be adding a lot more other content. Got some secret projects in the works. If you want to support me, if you want to see what's going on behind the scenes, you can check me out on Patreon. And if you just want to throw money at me, hit me up on Venmo. Any other way, PayPal, whatever. However you want to give me money. Bitcoin, I'll take your Bitcoin. Sure. It all goes towards supporting the show. It goes towards improving the quality. It goes towards things like mailing my guests microphones so they have even better audio than what you're accustomed to now. Continuing to make the improvements. Appreciate the support. If you enjoyed the show, leave some comments down below. Any future questions, anything that you'd like to have answered, I will have more academics, related researchers on these topics soon, as well as having Jessica back on the show in probably a couple months to check back in on her take on things. So I hope you guys enjoyed it and have a wonderful day. See you next time.